So we've got our ideas of samples and populations and statistics and parameters. From here, we want to get into the idea of variables. So a variable is a characteristic of interest for each person or object in your population. Essentially, it's what you want to know about. What is the GPA of a student at TCC? Is this person going to vote in the next election or not? Those vary from one person to the next. So we'll classify these as variables, and we want to classify our variables even a bit further as either a numerical variable or a categorical variable. And that's what we'll focus on in this video. So numerical variables have two characteristics. One, they take on numeric values. So you ask the person the question, and the answer you receive, the response is a number. It's a numeric value. And when you average all of those responses together, it makes sense. It has a meaning in the context. A higher number means you have more of something, and a lower number means you have less of something. GPA, weight, commute times, heights, temperatures, these would all be numeric variables or numerical variables. So, when I go and I ask 100 students, what's your GPA? The response would be a number. My GPA is a 3.2, my GPA is a 2.1, my GPA is a 3.95. And I could average those together, and the result would make sense. The average GPA of these students was this particular value, and that's higher or lower than this particular group. There are certain cases where the responses are numbers, but the average of those numbers doesn't make sense. It wouldn't have a meaning, per se. For example, phone numbers and zip codes as well. While the responses here would be numbers, I say, what's your phone number? I could get several phone numbers. I wouldn't want to average those together. I mean, that wouldn't make any sense. That has no meaning. What's the average phone number? Same thing with zip code. I mean, your zip code is a number, 32304, 31757, 32425. All of these are zip codes. But the average zip code doesn't have a meaning, because a higher zip code doesn't mean you have more of something, and a lower zip code doesn't mean you have less of something. It's describing location, which is not a numerical quality. It's where you are, not how much of something. Numerical variables are sometimes referred to as quantitative variables. Now, in contrast to numerical variables, we have categorical variables. But before we get there, let's talk about discrete versus continuous numerical variables. So we've got our idea of numerical variables, and we can break these down even further into either discrete or continuous. So discrete numerical variables can take on only certain numerical values. There is a clear step in between these values. The next possible number. The number of questions on a test, the number of students in a classroom, the number of people, business employees. These are all discrete numerical variables. For example, if I have a face-to-face class, the number of students that show up to class that day is numerical and it's discrete. The number of people showing up, I could have 30 people show up, I could have 31 people show up, I could have 32 people show up. So the responses are numbers, and I could average this over the course of the semester. Well, the average number of people showing up is 31.2. But as well, on a daily basis, when I'm collecting that data, there are distinct possibilities. I could have 31 people show up, and the next highest possibility would be 32. And then after 32, it would have to be 33. There's a clear step. I can't have any number between 31 and 32. I can't have 31.5 students show up to class one day, because how do you have 0.5 of a person show up to class? You can't have anything in between 31 and 32, and that's an example of a discrete numerical variable as well. Number of questions on a test. I could give you one question or two questions or three questions, but I can't really give you 2.754 questions. It's either two or it's three, and nothing really in between. Now, in contrast to the discrete numerical variables, we have the continuous numerical variables. And with continuous numerical variables, you have an infinite number of numerical values, even in between any two. And usually you see these continuous variables in things like distance and temperature and time, because these don't have to be exact. Something doesn't have to be exactly 3 miles away or exactly 4 miles away, but you can go in between. There can be 3.5 miles, it could be 3.2 miles, or depending on the precision of the tool you're using, it might be 3.245 miles. You have all of these possibilities in between 3 and 4 miles. Same thing with time. Something doesn't have to take exactly 10 seconds or exactly 11 seconds or exactly 12 seconds. When you're watching some Olympic races, maybe the 100 meters, we'll see those times get down to the thousandth of a second. It could be 10.078 seconds that it took the runner to complete the 100-meter race. And so because we have those values in between, and there are really an infinite number of those, depending on the precision of the tool that you're using, we would classify those as discrete. Now, as I mentioned earlier, if the data, the variable, is not classified as numerical, then we will classify it as categorical. So if your data set doesn't consist of numbers, or they do consist of numbers, but the average doesn't have meaning, then we have categorical variables. So categorical variables, as they imply, they place a person or object study into a particular category. Your eye color, your major, the state you were born in, zip code, phone number, these are all categorical variables. Going back to your eye color, we could randomly sample some people, 100 people on campus. What's your eye color? And the responses wouldn't be numbers, but say, oh, my eyes are blue, mine are green, mine are brown. We're not answering with a numerical value, but a word. We're categorizing these people as having blue eyes, green eyes, brown eyes. Same thing with your major. I could ask, what's your major? You're not going to say 8. You're going to tell me, oh, I'm a business major, I'm an education major, I'm an engineering major. You're going to categorize yourself in that way. And categorical variables are referred to as qualitative variables. Now, the data that we collect, these are the actual values of the variable. They're not the variable. The variable is what you're asking about, what you're studying. The data are the responses to your question about that variable. So I could say, well, GPA is my variable. I'm going to ask about that, and after I go out and talk to people, say, what is your GPA? And as those responses come in, that would be my data. Eye color could be our categorical variable. I'm going to go out and ask, what is your eye color? And the responses, the green, the brown, the blue, the hazel, that would be our data.